How does the miniature circuit breaker behave in the case of high inrush currents? A large capacitor, which requires a high charging current when empty, is connected to output 2. Now we switch over to the miniature circuit breakers, and as you can see, the second circuit breaker trips. Although the 2 amp circuit breaker is designed in characteristic C, that is for high inrush currents, the capacitor cannot be connected. The unintentional tripping can also happen when switching on electromagnets or DC motors. Only by switching on the miniature circuit breaker several times can the capacitor be successfully charged and switched on. How does the SEL1200 selectivity module behave, on the other hand? First, we see that the individual outputs are switched on consecutively, which limits the total inrush current and reduces the load on the power supply. And we see that output 2 has switched on without any problems, although it is also set to 2 amps. This is because the SITOP SEL1200 add-on module has a switching characteristic, which means that the SEL1200 allows very high currents for a short time. This enables capacitors or motors to be switched on where other protective devices would trip. The SITOP cell selectivity modules have a similar diagnostics interface to the PSU6200 power supply. For remote diagnostics, therefore, you also only need one digital input of your PLC, one function block, and faceplates. On the faceplate you can, for example, trace the time offset for sequential switch on. In this case, a 500 millisecond delay between one output and the previous one. In the next video sequence, we will look at the tripping behavior of the selectivity module and miniature circuit breakers.
Siemens. Ingenuity for life.